welcome back to the Land and Climate podcast. My name is Alasdair McEwen, and this time I've been speaking to the renowned environmental historian Dagomar Degroot about humanity's historical relationship with climate change. Dr. Degroot is an associate professor of environmental history at Georgetown University and an expert scholar on the period in climate history described as the Little Ice Age, which we will go on to discuss in this episode. He has a new book exploring the human relationship with the solar system, Ripples on the Cosmic Ocean.
I would argue that the goals of the new space, it depends on the company and the agency, but for the most part, they don't really benefit all of us. Elon Musk manages to bring 1,000 rich friends to Mars. They all get to pay lots and lots of money to get there. The overwhelming majority of people on Earth will not see a benefit from that. You could argue that humanity might eventually see a benefit from this, but most of us on Earth don't. What I believe in is returning to some ideas that were developed in the 1970s when people became disillusioned with the first space age, which brought the astronauts to the moon.
We started our conversation by discussing its main themes.
So the book is about how space has affected us, really. It's a book that reimagines the solar system as being part of human history and that reimagines the Earth as part of a cosmic environment, really a mosaic of environments. And those environments are changing all the time. And by changing, they actually impact us, not just millions of years ago, but even the last 5 centuries, which is what the book focuses on. So the book shows how everything from solar storms to small changes in solar output and asteroid impacts or the risk of asteroid impacts, dust storms on Mars, explosions on the moon, giant impact bruises on Jupiter's cloud belts, how all of that stuff has influenced human history. Then also actually a little known story about how we've started to change cosmic environments and the history of our thinking about changing those environments and how these changes are beginning to really materialize now that we're on the verge of what's often called a new space age, which is shaped by the ambitions of big space companies, new space agencies like the Chinese Space Agency is becoming a match for NASA in many ways. So it's about the changes that have happened naturally in space that have impacted our history and the changes now that we're making to space environments as we're embarking on this new era of human history. And then it's not just about the stuff that's actually happened, but the stuff that we've imagined or thought was happening. It's an unusual book, the environmental history of the solar system. There's a climate component to it as well, which I'm sure we'll talk about.
Okay, great. It's a really engaging book. I wondered if we could actually just start in perhaps the order of the book by, if you could tell us a little bit more about the sun's impacts.
The book is heliocentric. The book starts at the sun and then works its way out. So the last chapter of the book is about comets. And if you think about the structure of the solar system, of course, it's the sun at the center. And then it extends to about 1 light year away from the sun, where you have the outer edge of the Oort cloud. There's 1 trillion comets maybe in the Oort cloud. And the book has the same kind of structure. The book, though, is really focused on the sun because it's the sun that ultimately creates this sort of bubble in the galaxy, which is the heliosphere. And everything in the solar system is shaped by the sun. You can think of the solar system actually as the sun and some leftover scraps from its formation. And even now, the sun gives the structure of the solar system, right? Everything is revolving around the sun. But also, the sun is constantly bathing everything in the solar system with its solar wind. The cover of the UK version of the book is going to be the sun for that reason. And that's also how I started thinking about the book, at least in part, as I was working on my climate history stuff, my first book, The Frigid Golden Age. I realized, well, what's happening here in terms of the history of climate change is really governed by changes either on the sun itself or in the influence of the sun on Earth. So it's climate change. When you think about climate change, outer space environments are always involved. And so Ripples on the Cosmic Ocean starts with the perception of climate change during the Little Ice Age, a period of climatic cooling that's probably started in 13th, 14th centuries and was driven by a bunch of different things, one of them probably being small changes in the sun's output, how much radiation it releases into the solar system. But then also things like volcanic eruptions, which blocked some share of solar radiation from reaching Earth's surface. So the beginning of the book is about how people started thinking that the climate could change during the Little Ice Age. but then also how observations of the sun enabled with the telescope led astronomers to start thinking that the sources of Earth's climate, the origin of Earth's climate, which is the sun, by it changing, our climate could also change. So we really see the origins of some of the ideas around global warming, climate adaptation, climate resilience, even in the 18th and 17th centuries during the Little Ice Age.
Okay, and could we go into, for listeners, some more of these beliefs of the period? I know it's a lengthy period. I mean, it's 400-year period almost, or maybe a little bit more?
So we should maybe define the Little Ice Age a little bit. This is a complicated period, and it's often thought of as just being a period of cooling. But that's not quite the case. The time period itself is debated. Some people argue that it started in the 13th century, because that's when you have the first cooling in the Arctic. Some people argue it started in the 14th century, so that's the 1300s, because then you've got one of these lows in solar output called the Wolf solar minimum, and you've got a series of crises in Europe, so the cooling extends into Europe around that time. Others argue it started in the 15th or even the 16th centuries, because that's when the cooling gets more severe, or it gets global in the 16th century. So there's all kinds of debate about when it started, less debate about when it ended. It seems that happened around mid-19th century. So it's a contested period. What's certain is that there were waves of cooling that affected some regions more than others, reached some regions at different times than others, but were all pretty modest when you compare them to the magnitude of present-day warming. So Little Ice Age, we're talking about a cooling in the chilliest decades in the northern hemisphere of certainly not more than 1 degree Celsius, and probably more like 0.5 degree Celsius. And global warming already is 1.5 degrees Celsius of warming. So the Little Ice Age is often compared to global warming in terms of the magnitude, but these are two different things. And the cooling during the Little Ice Age was much less homogeneous than the warming of global warming. So you've got this cooling happening in different places at different times. And that's also because of what's causing the cooling. We know that volcanic eruptions were part of the issue here. Big explosive eruptions that released sulfuric gases into the stratosphere, where chemical reactions turned them into dust, basically. But the dust didn't blow across every part of the Earth's surface to the same extent, and the dust tended to precipitate out of the atmosphere after a few years. And then you had another eruption in a slightly different place. The cause of the Little Ice Age was so complicated. And then you have things like precipitation mattered a lot more than temperature in some regions. So there's severe droughts in parts of the southern hemisphere that mattered a heck of a lot more than how cold it was. And you've got increased variability of weather because basically you have a change in the places where you could get storms. So the storm track in part of the northern Atlantic moves further south. So there's a whole bunch of different things going on, lots of moving pieces, and it's very, very complicated. But even though it's smaller in magnitude than present-day warming, what's crucial is that many people depended a heck of a lot more on weather than present-day people and thought much more about it. The weather really dictated your day-to-day life. The vast majority of people worked in agriculture, or at least in subsistence. So their day-to-day lives and their monthly and year-to-year security depended profoundly on the weather. So we know that, but at the same time, our ability to access the ideas, the thoughts, the experiences of these people is really limited because the sources we have ultimately were written by elites, many of the sources, not all, but many. So what we're really seeing is an elite perspective on how ordinary people lived. Those elites also, though, happen to be a lot of the people in their society who are least dependent on the weather. So it's difficult to know exactly how people are thinking about weather, let alone about climate and climate change during the Little Ice Age. What we have are things like an elite person saying, hey, it seems like some people, some farmers might be thinking that the weather is getting worse. Things like that, where you have indications of popular beliefs that at least extreme weather conditions are getting more common, or the dates of the harvest might be changing, things like that. That's pretty much the best we can do for most of the Little Ice Age.
Yeah, it was also interesting to read in your book. I feel fairly ignorant on this, is around at least Western ideas on climate. If you wouldn't mind just explaining the neo-Hippocratic ideas and those of Aristotle as well, that'd be really interesting for listeners.
In the West, there's this conception that climate is the same thing as latitude. Latitude is how far north or south you are. This was a huge surprise when explorers and settlers arrived in the Western Hemisphere, and they realized that things were a lot more complicated than that. So the weather in Canada is not going to be the same as the weather in Europe at the same latitude. It's going to be a lot colder for most of Canada. And then there were all kinds of competing theories as to why that was the case. And some people thought, well, the First Nations peoples of the Western Hemisphere had not sufficiently civilized the continent, and therefore Europeans were entitled to come in and tame the continent and thereby warm its climate. But there were also thinkers who started imagining how water and air could move to affect different temperatures in different continents. And these are the origins then of today's understanding of atmospheric and oceanic circulation and how that comes to then affect continental climate. Then there's this idea, which existed in tandem with the notion of climate, of the purity of the air. Purer air, cleaner air was more conducive to human health. And you could, in fact, purify the air by practicing agriculture and settling a territory in the right way. So these are all elite ideas. And the extent to which these notions percolated down to like the ordinary farmer in the Low Countries, let's say, so I've written quite a bit about that. How are they thinking about climate? It's actually quite difficult to establish. Do they believe that the climate can change for natural reasons? There's also a lot of talking about the kind of contradictory and complementary ideas that are all existing at the same time. It's also this notion that divine displeasure can alter weather conditions. And if people sin, then extreme weather will be visited upon them. And even then this notion in the 16th century that bad weather comes from demonic forces. There's not God, but demonic forces. So there's a lot of contradictory ideas. When we think about this time and climate thinking during the Little Ice Age, we imagine a straightforward transition from classical ideas about climate, like latitudinal climate lines, to a modern kind of science based on our understanding of the movement of air and water and our understanding of forcing. But it's much messier than that and a complicated process where some of the foundations of modern-day climate science stretch back much further into the Little Ice Age than people have assumed.
And at what stage was there a wider recognition that there had been a Little Ice Age?
You can answer that question in many different ways. So the first way of tackling it might be to think about whether people at the time realized they were in a colder climate. That should lead us to think about the nature of the sources that we have available to us, especially in the history of climate scholarship. We call them the archives of societies. So these are anything really that's created by people that tells us how people endured and understood the weather and the climate around them. The archives of nature are things in the natural world that in some way preserve the legacy, preserve the impact of climate change within their composition. And you can, by studying their composition, obtain a record of climate change in the past. So the archives of societies for the Little Ice Age are very diverse. There's many different kinds of them, from direct observations of weather that we might get in the journals kept by sailors. Those are called ship log books, to like actual weather diaries where people, usually elites, in fact, exclusively elites, are talking about their experiences in the kind of weather we now associate with the Little Ice Age. And in these sources, sometimes we get intriguing glimpses that people were thinking about a climate where at least extreme weather was now more frequent than it had been. So we get these references to extreme winter conditions or extreme storminess at sea that was not like anything anybody had experienced before. And if you actually go back then and try and determine, okay, well, is that true? When they are saying these things about nobody ever having experienced these conditions before, are they right? Then using the archives of nature, you can determine that, yeah, it's true that at least for 50 years, 100 years, nobody had experienced these conditions before. So they were keeping track of things that were legitimate, that were real and genuine in their environment. But you also have sources that can tell you about adaptation to climatic conditions without telling you that people are recognizing that those conditions are occurring. So this gets a little bit complicated, but things like how wars are fought, are they exploiting new wind patterns? Or things like how people are now trying to exploit resources, like when are they leaving to go to whaling grounds in the Arctic in the year? Are they leaving later in the year? So you get these indications that people are adapting to climate change without getting that kind of smoking gun source, like we're leaving later in the year because there's more sea ice in the Arctic and it's harder for us to catch whales in all that ice. And then lastly, now we're leaving a few things out, but lastly, you get these rumors of popular beliefs around the climate getting colder and it being harder to grow things. If you actually look at sources that come from ordinary people who might have been working on farms, you might get no indications of these beliefs at all, because often those sources, those letters, were dictated and written down by literate people. Most people weren't literate in most societies. And they follow a template that is very low on weather. But these people were working with the land, which again, the majority of the people in the contemporary world must have been aware that things were getting colder, right? Because they were so attuned, like their entire life depends on what my former student, Emma Mosweild, calls the seasonal round. Activities that had to be done at different times of the year in order to grow food or preserve it, and were exquisitely sensitive to changes in weather and climate. So there's a huge repository of knowledge, climate knowledge, that the elite sources, the written sources we have, only hint at from time to time. I touch on those kinds of sources a little bit, but they are quite limited. One other thing I'll say here is that we're talking about now, when we talk about these archives of societies, we're talking about the perception of climate change, of that the weather is different. But you can also talk about the perception of forcing. So forcing is something that causes the climate to change. And what happens in the 17th century is usually called the scientific revolution, a series of developments where experimentation and observation become a lot more important in European and ultimately in global thought. And the origins of this scientific revolution are really complicated. It's clear now that they involved global information exchange that had all kinds of sources, from sailors to First Nations communities and on and on and on. But the upshot is that people start to do things like construct instruments that let them observe the sun, right? The telescope. And they're able to see that the sun, which very clearly is a source of weather on Earth, goes through changes. It's not a perfect ball. Sometimes there's more sunspots. Sometimes there's fewer sunspots. There's stuff coming out of the sun. It's a variable place. And by the 18th century, some have also realized that the stars are not constant, that there are variable stars that actually change their luminosity. And of course, you can just imagine where this is going. Astronomers will begin to think, well, what if the sun changes? What will happen to the climate on Earth? And even in the late 18th century, there are ideas of, well, maybe the sun has changed before. When it changed, the climate cooled, there was less food to go around. And when there was less food to go around, there were political crises. So we should guard against that happening in the future. And this is now, all of these things are what we associated with the Little Ice Age. So you can argue that by the late 18th century already, while scholars were still in the Little Ice Age, in some ways at least, they perceived the basics of what we now associate with the Little Ice Age.
How much does thinking on the Little Ice Age actually give us an insight into the current emerging beliefs and political discussions we have around global warming?
One way of going with this is to think about outside of European history, because the Little Ice Age had global impacts, and there's an increasingly global scholarship about the Little Ice Age. And one really long-standing and influential foundation of that scholarship is Chinese. The Chinese scholars have been thinking about the Little Ice Age for decades, well before I was born. A lot of their thinking on its social impacts has to do with the Confucian concept of the mandate of heaven. This idea that the emperor was the son of heaven and that the stability of the climate on earth depended on heaven's favor. So if the emperor was ruling effectively and justly, then the climate would be benign. But if the emperor was unjust, there'd be these weather extremes and the climate would start to destabilize. What this concept of the mandate of heaven, some have argued, what it provided for the Chinese people and elsewhere where this concept also existed, like in Korea, was a mechanism by which to change their government when a climate disaster hit. I'm immediately reminded of what's happening in Madagascar right now, where government is being toppled in part because government is not providing services in the wake of very severe climatic extremes. And you can just see how people are not using the mandate of heaven, but they are blaming their governments for a lack of response or a lack of services in the wake of climatic extremes. And there I see a very strong parallel between what happened in the Little Ice Age and what's happening now. And you can just imagine as well, as we start getting these profound climate catastrophes like extreme droughts, inundations, devastating heat waves, a lot of people, I think, are going to blame their governments, and in some cases, rightfully so, because, in fact, now governments are indeed causing their disasters that are happening around us by not limiting greenhouse gas emissions. It's a tragedy what's going on here in the United States. Georgetown University is a unique university. A lot of our students want to go into policy. A lot of young students, whether they're conservative or liberal, believe that the climate is changing. I think there's a real desire for us to at least get on the same page with that. That's what I really lament here in the United States, because I've advocated for progressive solutions to the climate crisis. I'm a fan of Green New Deal legislation because it is comprehensive. It captures the comprehensive nature of the climate crisis, where things like reducing social economic inequality is an important way that you can have a more climate resilient society. Conservative and small government responses to Green New Deal legislation that I can respect. What I cannot respect is us not being able to accept that the climate is changing when everybody secretly knows it is. And of course, the science is comprehensive and conclusive. That's the greatest tragedy that I'm perceiving right now in the discourse here in the United States, where in the year of our Lord 2025, we still cannot agree that what's happening so plainly in front of our eyes is in fact occurring.
You've got a very good analysis of many epochs in your current book, and I know you've obviously extensively researched Little Ice Age as well. In some ways, you're also an analyst of survival. I wondered if you could talk a little bit about survival, what it meant then in some of the epochs that you've studied and what it might mean for now.
Survival, I think, of humanity is a pretty good prospect in the sense that even worst case scenarios of climate change, it's very likely there'll still be lots of human beings on Earth. They won't be living as well. There might be fewer of them, but I don't think that it's a realistic prospect for global warming to bring about our extinction in the next few centuries at least. However, don't care too much about that because as the great climate scientist, one of my favorites, Kate Marvel says, we should be aiming for a little more than not going extinct. As a father also, I would like my children to be able to thrive on a world that's better than the one in which I grew up on. And climate change is one of the leading threats to that being possible. So survival right now is perhaps not at stake for humanity. It is at stake for hundreds of millions of people around the world. And that's where you get to capacity for humanity to thrive. And maybe I'll start with that. I'm really worried about tipping elements in the climate system, what are sometimes called tipping points. And there are many interconnected tipping elements. We call them tipping elements because they turn out to be a lot more complicated than just tipping points. They don't just automatically trigger, and we don't know exactly how they automatically trigger. But the upshot is that these are parts of the climate system that can switch to new states. And once they begin to switch, it's almost impossible to switch them back again. So something that I've worked on quite a bit is the Atlantic meridional overturning circulation, which is this huge conveyor system. You can think of it as a pump in the Atlantic Ocean where warm, salty water travels north. Because it's salty, as it cools down, it gets denser. It sinks deep below the surface of the ocean and is replaced by fresher, cold water moving south. And it's just this massive conveyor belt. And it really regulates Earth's climate. Winds blow over the warm, salty water following Earth's rotation. They blow from the west. And because of that, Europe is actually warmer than North America at the same latitudes. This going back to these like early modern, these little ice age discoveries. But also because of this, the monsoon systems are as strong as they are and precipitation patterns are what they are globally. The Atlantic meridional overturning circulation, or AMOC, is slowing down right now. And there's diverse evidence, including climate models, that suggests that it will in fact start to break down this century. With the odds of it breaking down going up, the more we've warmed the Earth. And this is really bad. If this AMOC breaks down, then Europe's winter temperatures collapse, even as its summer temperatures continue to rise. So you've got this incredible shift in seasonality where you've got brutally cold winters across much of Europe and an overall annual cooling, but the summers are actually getting hotter. Agriculture becomes much, much more difficult in Europe as well. The monsoons will also weaken across South Asia, for example. So it basically gets a lot harder to grow food. And when we look at the past, so I have this multimedia project called the Climate Chronicles, where I talk about the Pleistocene geological epoch, which is the epoch in which we evolved, the epoch distinguished by extreme climate changes on many different scales. But what happened in the Pleistocene is the AMOC shuts down again and again and again, most recently during something called the Younger Dryas, beginning 12,900 years ago. So we know that this AMOC can shut down. And we know why it can shut down, partly because of meltwater streaming off of retreating glaciers or ice sheets, which then alters the salinity of this warm, salty water moving north. That's what's happening right now. So we know that there's a similar cause in the past as what's going on now. And we know that when this AMOC shuts down, hunter-gatherer populations around the world, so small groups of humans who live then, were hard-pressed to survive. And many of them could only survive because they were able to migrate far afield. They could travel to places where there were still resources available. And of course, it's hard to move now hundreds of million people across national borders. So in some ways, populations of humans are less able to adapt to today's AMOC breakdown that may be occurring versus those that happened in the past. I'm especially worried about the AMOC.
You referred to your Climate Chronicles podcast, which is excellent for listeners to go to. So we will put a link to that in our podcast blurb. In that, you actually refer to what I found quite interesting. One of the things that you say is that we live in a remarkably cold period in Earth's history. One of the quotes is that humans are children of the ice. Can you say just a little bit more about that as well?
Absolutely. And this is a common source of climate misinformation. In fact, this is something that Joe Rogan has referred to recently, to my infinite frustration. But it is possible for us to live in a really cold stretch of Earth's history and for us still to be at risk of warming. Those two things are not mutually exclusive. We are at the tail end of 50 million years of climatic cooling set in motion by the collision of tectonic plates, which raised up the Himalayan mountains and through precipitation started scraping carbon dioxide out of the atmosphere. And from that, all kinds of other things happened. So at the start of the Pleistocene geological epoch, 2.5 million years ago, the Earth was as cold as it had been in tens of millions of years. And what we have then is the formation of ice sheets. Beginning about 35 million years ago, ice sheets are very big glaciers, and ice sheets usually don't exist on Earth's surface. For 90% of Earth's history, there were no ice sheets. We are indeed on what's still called an ice age. An ice age is just when there's ice sheets on Earth's surface. So we're still in an ice age. But it just so happens that our entire society is built around the Earth, an ice age Earth. Our cities are all clustered around the coast. And if the Earth starts to warm up, so it becomes like the Earth usually is for 90% of its history, guess what? We lose all of our coastal cities. It shouldn't comfort us to realize that the Earth is not normally like this. We are completely dependent on the Earth staying like this. And the same is true for today's ecosystems. Today's life has evolved to adapt and accommodate itself to an ice age Earth. So if you then abruptly change the Earth back to the way it was, or again, 90% of its history, then, the species that exist today, many of them will not be able to cope. And the range of those species in which they live right now, their ideal range will change dramatically. And what's worse is that our societies are in the way of animals being able to migrate, right? So on this human-dominated Earth, species, plant and animal species cannot adapt like they once did. So it's both true that we live in a very anomalously cold period in Earth's history, and true that a warming so that the Earth reverts to the way it has usually been is a severe threat to us.
And it also says something about humans' changing relationship with nature, arguably, historically.
Yeah. So in the Pleistocene world, humans were a highly adaptive animal. We evolved big brains. Hominin species evolved big brains, in part because it allowed them to cope with an unstable world. Even though big brains had all kinds of disadvantages as well as advantages. The big brain requires a ton of energy. The big brain makes childbirth a lot more dangerous. So there's a lot of disadvantages to big brains, but the advantages outweigh the disadvantages. Otherwise, we wouldn't be here. And big brains did allow us to navigate a Pleistocene world, in part, and most importantly, by migrating. So we were able to move, not just because the climate changed in ways that forced us to move further south, but also because the climatic changes of the Pleistocene world opened up corridors through which we could move to settle new parts of the world, including the Western Hemisphere. So we were able to exploit radically shifting and fluctuating Earth, as well as to be able, again, to survive those changes. We were part of nature. We were like many other animal species. And it's actually a fascinating question of when we started to become an anomalous part of nature. You can come up with many dates. This is connected to the Anthropocene. So when did humanity become one of the great forces of the Earth system, to such an extent that it actually we imperil the Earth system, the continued functioning of the Earth system. And a date that I favor is actually far back in time. I think even in the Pleistocene, Homo sapiens began to evolve culturally, most importantly, I think, into a radically different animal that was able to transform environments on a spectacular scale, potentially also on purpose. So you see that with things like controlled burns. So the whole environment of what is now Australia changes dramatically when Homo sapiens arrive. And we start burning the landscape, dramatically increasing the extent of grasslands. We start killing megafauna, big animals on a colossal scale. So the Australian environment, very quickly after we arrive, becomes totally different from what it was before. And the same applies in many other parts of the world as we start to migrate out of Africa. So for me, at least, already in the Pleistocene, humanity, Homo sapiens, becomes a different kind of animal. Other possible starting points for the Anthropocene might include the development of agriculture, which could have had a climatic impact through methane emissions. But the most popular ones are the beginning of industrialization in the late 18th and 19th centuries and the mid-20th century, where there's a whole series of changes, but perhaps most importantly, the first atomic bomb tests.
I'd like to move on to your writing about space exploration. And you mentioned exploiting resources, and you've got some very interesting ideas. And maybe you could say a little bit about your ideas on more democratic space exploration and that current programs aren't necessarily acting in the wider public interest.
Yeah, I don't think so. So what is the purpose of space exploration is something that is a long-standing, huge debate among anybody who works on space. And the stated purpose and the real purpose are often at odds. And of course, there are multiple purposes. So we're talking about really the dominant purpose. The space age begins in 1957 with the launch of Sputnik 1. And since its beginning, I think you could say that the principal purpose of space programs has been to signal something about their countries, at least during the heyday of the first space age in the 1960s and early 1970s. So the United States and the Soviet Union got in this race to land people on the moon, but they also got in races to explore the moon robotically, explore the planets robotically. And the reason that attracted hundreds of billions of dollars in funding is because not just landing people on the moon, but returning useful science from other worlds was a way of signaling the superiority of your political and economic systems. Now, since this first space age, you could say that space has been commercialized, near-Earth space at least. And so now we depend on space exquisitely for our day-to-day lives. We depend on space to communicate. We depend on space to know what the weather's like. We depend on space even to know where we are because of GPS. So space now is intimately entangled with our day-to-day lives. And that has been a really important component of space, I would say, space age, space travel, since the space race of the 1960s. But now we are again seeing, I think, a change, a new space age, as some people call it, where we have the emergence of these mega companies like SpaceX. SpaceX is actually responsible for 90% of everything that's launched into outer space, of the payloads launched into outer space. But we also have then the emergence of many more space agencies. And again, most importantly, the Space Agency of China. And what space agencies and new space companies have in common is a desire to use space resources, really to use them on a large scale, partly in order to bring people into space environments and to have them stay there, and perhaps even to have them settle on the moon or on Mars. It seems like a dawning era of space resource exploitation and space settlement. And of course, for space companies, there's a constant search for how you make this profitable. And SpaceX is now fantastically profitable because they found out how to use the satellite constellations in order to turn a profit. And of course, they've got many different contracts with government and companies to launch things into space orbit. They've pioneered reusable rockets, which really democratizes access to space, makes it much cheaper to get there. You see a company called Blue Origins that has pioneered space tourism, very controversial. Obviously, it's the rich get to go into space, the rest of us don't, but they can turn a profit that way. The vision is bringing people to space environments. I would argue that the goals of the new space, it depends on the company and the agency, but for the most part, they don't really benefit all of us. Elon Musk manages to bring 1,000 rich friends to Mars. They all get to pay lots and lots of money to get there. The overwhelming majority of people on Earth will not see a benefit from that. You could argue that humanity might eventually see a benefit from this, but most of us on Earth don't. What I believe in is returning to some ideas that happened, that were developed in the 1970s when people became disillusioned with the first space age, which brought the astronauts to the moon. And some people started thinking about, well, how can we make space beneficial for everybody? They started imagining these ways of extracting resources from space, using space environments, space resources to build cities that would beam solar power to the Earth. These are called O'Neill settlements. Rotating cities in space. By rotating, you create your own gravity. And it's kind of a utopian idea, but the fear was overpopulation at the time. And so these cities were ways of allowing people, ordinary people, to move into space to beautiful new environments where they would also beam clean energy to Earth. And that's the kind of idea that is very attractive to me because it helps address one of our biggest problems on Earth, which is our energy use and how so much of that energy use ends up polluting the Earth. It also then transforms space settlement into something that can be done for everybody. And it gets around what I consider to be a huge problem in space settlement dreams, which is the fact that the planets and the moon are just not good places to live on. Mars really sucks. Its soil is toxic. It's bathed in radiation. It's extremely, extremely dangerous. The moon is even worse. Some people point to the cloud tops of Venus, but I mean, if that's where you want to settle, that's pretty grim. I think that technologies are now converging in ways that make these visions from the 1970s more plausible than they were then, particularly artificial intelligence, which allows for automated construction in outer space, 3D printing, which allows robots to build more robots, to really have an exponential sort of increase in building capacity in outer space. The development of reusable rockets, which allows you to launch much more payload into outer space, also permits for things like Starship refueling in outer space, which is paradigm shifting. So you've got now the maturation of technologies that should allow for large-scale construction projects in space. And I think it's time to imagine how that could be done for the benefit of everybody on Earth. One thing we're sure of, which is that what's happening on Earth right now is unsustainable. The way that we use energy, the finite nature of our resources on Earth is not sustainable. But in space, there's infinite energy, and there's essentially infinite resources. So now's the time to start thinking about how we can use those for the betterment of the Earth and the preservation of Earth environments.
Thanks very much to Dagomar Degroot for his time. His new book, entitled Ripples on the Cosmic Ocean, an environmental history of our place in the solar system, is just out now for readers in the US and Canada. And for UK listeners, it will be out on the 26th of February next year. That's 2026. I'm afraid I haven't got all the international publication dates for everyone and for all countries, but we do have links to the publishers in the blurb, so do look at that. You might have heard us refer to it in our chat, and Dagomar has an excellent podcast called The Climate Chronicles that I'd highly recommend. And we also link to this and some of Dagomar's further reading suggestions in our podcast blurb. As usual to say, there's now a back catalogue of more than 100 episodes of different podcast interviews and topics, which you can find on our website at landclimate.org or on your podcast platform. Thanks very much to Vasco Kostovsky for audio engineering the show, and we'll be back in a fortnight with a fresh interview. I'm Alasdair McEwen, and thanks for listening.